The video game graphics rendering pipeline has three key steps: vertex shading, rasterization, and fragment shading. While additional steps are used in many modern video games, these three core steps have been used for decades in thousands of video games for both computers and consoles, and are still the backbone of the video game graphics algorithm for pretty much every game you play. Let's begin with the first step, called vertex shading. The basic idea in this step is to take all the object's geometries and meshes in a 3D space and use the field of view of the camera to calculate where each object falls in a 2D window called a view screen, which is the 2D image that's sent to the display. In this train station scene, there are 1,100 different models, and the camera's field of view sections off what the player sees, reducing the number of objects that need to be rendered to 600. Let's focus on the locomotive as an example. Although this engine has rounded surfaces and some rather complex shapes, it's actually assembled from 762,000 flat triangles using 382,000 vertices and 9 different materials or colors applied to the surfaces of the triangles. Conceptually, the entire train is moved as one piece onto the view screen, but actually each of the train's hundreds of thousands of vertices are moved one at a time. So let's focus on a single vertex. The process of moving a vertex, and by extension the triangles, from a 3D world onto a 2D view screen is done using 3 transformations. First, moving a vertex from model space to world space, then from world space to camera space, and finally from the perspective field of view onto the view screen. To perform this transformation, we use the X, Y, and Z coordinates of that vertex in modeling space. Then the position, scale, and rotation of the model in world space, and finally, the coordinates and rotation of the camera and its field of view. We plug all these numbers into different transformation matrices and multiply them together, resulting in the X and Y values of the vertex on the view screen, as well as a Z value or depth, which we'll use later to determine object blocking. After 3 vertices of the train are transformed using similar matrix math, we get a single triangle moved onto the view screen.